Okay, good afternoon everyone. Welcome to my presentation. As seen from the page, from the slides, if you don't like the weather in CAIRO, just wait few minutes. So of course, it's not set for CAIRO, it's set for England, but this means that the climates are changing. So climates are changing, and of course it is affecting the human life, animal life, plants life, so many things in parallel. So what I can say for that, most of the words you see here, environment, seasonal change, climate crisis, many things, fossil fuels, carbonization, decarbonization. We know something about that, but sometimes these words becoming like more social. So we don't really believe that each and every sector, each and every industry is being affected by this. So my presentation, you go to the next one. So you see the content here. So briefly, my presentation is with two parts. One is the real definitions of the climate change, climate crisis, carbonizations, carbon emissions, greenhouses, etc., including the reasons of the climate change. The reasons, of course, there are some consequences of the climate change, the results of the climate change. So if we go to one next, simply let me start with the greenhouse effect. So greenhouse, they are not bad. There are natural greenhouses. So solar radiation, solar rays, when they arrives to the earth, and it reflects back, and then it is collected in the atmosphere. So they keep, so re-emitted them. So if you go to next slide. Okay, so what I can say, what is global warming? Global warming is the temperature anomaly. Means 1880s, during these times, the anomaly of the increase, the anomaly was around zero because there was no industrialization. But then, after the First World War and after the Second World War, so industrial revolutions has happened, then the world started to increase. But of course, if there was no any greenhouses, the world temperature, average temperature of the earth would become -18. So greenhouses, the natural greenhouses like carbon dioxide, methane, N2O, nitrous oxide, they are good up to a certain extent. But after that, when man-made refrigeration systems, air conditioning systems come to our life and increasing day by day, year by year, and then we started to make some man-made greenhouse gases. So today, around 22 years ago, you see the temperature increase of the earth. The average temperature of the earth is reaching to almost 2 degrees. So in 2 degrees, we'll see what is happening. Next, please. Okay, as I said, the greenhouses summarized in this picture. So these are the natural greenhouses, carbon dioxide, methane, and the nitrous oxide. But of course, the fluorinated gas that they are available in the refrigeration system, like HFCs, SF6, NF3, or perfluorocarbons. So they are really increasing the anomaly of the temperature of the earth. So increasing day by day, and we'll see what's going on when we exceed a certain limit. So there you see one of the, or several reasons actually, resulting the increase the carbon emissions. So burning fossil fuels, the fertilizers, pesticides, and increasing the livestock. So some of them increasing the CO2, and some of them are increasing the nitrous oxide. And of course, fluorinated gas in the refrigeration systems, air conditioning systems, also has very bad impact to the greenhouse emissions. This actually very interesting graphic, because air conditioning industry, our industry, HVAC-R, you see the distribution of the greenhouses and the amount of the greenhouses because of the sectors. For example, here the yellow area, you see they are CO2, fossil fuel, and the industrial process. So from that time, from the beginning to 2010, you come here, you see it's around 65%. So burning fossil fuels is making a bad impact, negative effect to the greenhouse gas emissions by 65%. This one, the red area, is representing the CO2, forestry, and the land use. So again, it is also very much high, 11%. And when we come to the nitrous oxide, as I said, livestock animals, so anything making nitrous, so it is making like an effect of the 16%. So when we come to the air conditioning, refrigeration systems, it is only 2%. And in the beginning it was less. As you see, the dark blue line you see here, it is unvisible almost, but year by year the effect of the fluorinated gas, refrigeration systems, gas is increasing by 2%. So question, maybe you can raise me this question. Are we going to talk about 2%? So the effect of the fluorinated gas in the AC or refrigeration system is only 2% and we are talking about it? Yes, definitely yes. Once you see the effect of the fluorinated gas for the CO2 emissions, you will be surprised. And if you make a slight change of the efficiency of the refrigeration, for example, or efficiency of the chiller, for example, you will be seeing the saving, protecting the environment for that. And of course, you see the refrigeration gas by gas, so the greenhouse emissions by the gas. Again, F-gas, fluorinated gas, man-made gas, so we can say synthetic gas too. So you see carbon dioxide from the fossil fuel, any fossil fuel, carbon dioxide from the land use, methane, nitrous oxide, and the F-gas. The next slide, you will be seeing the greenhouse emissions by this sector. So this is making some sense for air conditioning industry. Probably all of us, maybe majority is in the HVAC-R business. So you see, greenhouse emissions by economic sector is the bigger part here, the electricity and heat production. So we are producing electricity and we are emitting greenhouse gases to the earth, to the atmosphere. Our sector, of course, air conditioning units, refrigeration units are being used in the buildings. So the building is keeping 6% of the greenhouses. But when we go to the buildings, 37% of the 6%, they say, is coming from the HVAC system. If we come to the next slide, we see the country-wise greenhouse emissions. So to give you an idea about that, China, 30%, United States, 15%, India, European countries, and others. So you see the distribution of the greenhouses by the continent or the country. We go to next slide, and of course, we must be talking about the consequences, the result. So what will happen? What kind of difficulties we are having when there is climate change or climate crisis? This is how you designate climate change or the climate crisis. This is simply the consequences. You know all of this. Yes, you are hearing from the news, you are reading it from the newspapers, and you are hearing so many things, but we must understand the real consequences, the results, the outcome. If we go to next, I don't want to go into the details because it's too much. Unfortunately, it is too much. So there are natural consequences on the, of course, bad consequences, bad impact to the environment. So high temperatures, everybody is feeling it. Maybe today Cairo temperature is more than normal, 6%, 3%, whatever. So the high temperature, and there are, each, and the problem here is high temperature makes drought and the wildfires. So each and every reason of the climate change, they have a cross-cutting effect. So one, high temperature is causing drought and wildfires. High temperature is also changing the types of the spaces, the animals, the biodiversities. I've just heard from Turkey newspaper that the scientist has just discovered a new scorpion, and it is resisting to any conditions. So 10 minutes it can send a human being to the land. So every consequences has some cross-cutting effects too. Of course, availability of the fresh water. It's becoming more difficult to find the fresh water to drink. And floods have bad effect to the environment, and also floods, when they are mixing with the fresh water, the quality of the fresh water is also decreasing. So as you see, there is a cross-cutting effect to each other. Next one, sea level rise. So Arctic is unfortunately one of the places that is going to be affected too much. And biodiversity, different spaces, different animals, different viruses. So they're all cross-cutting. We go to next, we see the soils, salination, the material, the structure of the soil is changing, and then plantation is different. Agriculture is going down. Quality of the crops, was also badly affected for that. Inland water is also affected too much. Marine environment, the spaces under the water, they are also affected because temperature of the water is changing, so spaces are really affected. Health, for example, the viral zoonotic diseases, vectorial-borne diseases, they are changing their structure. So that's why when we get flu or cold these days, we are coughing like 1 month, 2 months, it never passes away, it never go away. So that is the main reason. Vulnerable population means the people who need special attention, special care. So they are under the effect too. So when the temperature increase, they are not able to survive in the high temperatures, or sudden changes of the temperature is also affecting too much. Employment, they are migrating, they are leaving their countries because agriculture is decreased or industrialization is decreased, so they have to move. So you see, it becomes an effect, bad effect to the demography of the countries. So you are losing the employing or educated people to other countries where the effect of the climate change is less. Education, as I said, and more and more. Okay, there are of course the threats to the business too. Infrastructure, you have to make resisting buildings. You have to make different buildings, because sea level rise is affecting of the corrosion of the infrastructure of the steel. So you have to make different buildings, stronger buildings. So it affects directly the infrastructure of the buildings. Energy, of course, the demand is changing. Next slide, I'll be showing you how Egypt is affected by the energy demand. Year by year, Egypt, energy demand is increasing too. Agriculture and forestry, temperature rise, pattern of the events, pattern of the rainfall, pattern of the, the hot days, degree days are changing. So the things and everything is changing, especially for agriculture and forestry too. So we are losing. Tourism, of course, so they decline. So we don't know the pattern, of the weather in the, normally we used to go to places for tourism, but the weather is changing. Or floods, we don't expect floods these days, but it started to happen. And of course, cross-cutting business is also very major problem. So supply chain system, for example, there was COVID 3-4 years ago, supply chain system was distorted. There was no any regular supply chain. I'm not going to go into the details of the territorial changes because they are changing day by day too. Arctic. The question, why is Arctic affecting majorly for the climate change? Because there are glaciers, the ice, they are just lying there, and when the sun rays is coming, it's reflected back to the atmosphere. But when you lose the glacier, they are melting, they are not reflecting back, they stay. So that's why Arctic, the poles, they are affected by the climate change more than anything, more than anything. Okay, see, understanding the Egypt, first of all, there are some, of course, these are bad things, the bad impacts of the climate changes, but some countries, they are taking some actions for that. So Egypt is one of them too. So Egypt is a part of the Montreal Agreement, the Kigali Amendment. So they are now working to ratify, to confirm that I am going to be the part of this agreement system and I want to prevent the climate change. For example, if you come, just a couple of points about Egypt. Climate, you know better than me, dry and hot and predominantly desert. And for example, average annual temperature from 1980s, 0.53 degree increase. So imagine 1 degree of the temperature change in any territory, any region, city, province, whatsoever, is affecting too much, everything. For example, of course, the distribution of the electricity demand in Egypt. You see, the demand based on the sectors, forestry, land use, waste, energy, and also for Egypt you have the 44% residential sector is the highest consuming sector for them. So you see the distribution by the numbers of the fugitive emissions and other sectors too. So Egypt is affected too much too. Okay, so far we understand that there's a climate crisis, climate change, global warming, greenhouse effects, so all bad things, but there are some actions. Actions, unfortunately, to mitigate the anomaly, not to reduce, not to remove completely. We cannot remove. Population is increasing, energy demand is increasing, so we cannot remove it. But what we can do is, there are some multiple of chain of the agreements, probably you know all of them, you hear, from article to article, you know, newspaper to newspaper, television too. So there are some actions for that. I'm going to be mentioning about the actions very shortly so that you understand. Come back, I want to point out something. European Green Deal, you started to hear about them. Emissions trading system, there are some quotas to each and every country. So you are not able to make importation of the refrigerant gas. They are putting the quota. And Egypt is going to be affected by the quota too. Soon or later. Carbon capture. Yes, you are just capturing the carbon dioxide when they are just moving the earth and going to atmosphere. Adaptation to the climate change too. What I am going to be, just come one slide next. Today I am going to be focusing on the fluorinated gas. So they are man-made greenhouses to affect the global warming too much. And of course there are some reducing the global warming potential of the refrigerant. And also, there are some actions on the energy efficiency-wise. I'll be mentioning about them. These are also other kinds of actions. So, transportation emissions, renewable energies, forest and agriculture in a different, small area, but more efficient. So, they are all actions. We must be following each and every actions to reduce the temperature anomaly and global warming, and of course the climate crisis accordingly. Now we are here to express what is going on year by year. For example, there were some agreements from the Vienna Agreement, Montreal Agreement. So the first target the world reached, so 2020, the target of the cutting the greenhouse gas emissions from the 90 levels, okay, by 20%. And 20% of the energy has to be from renewable energy, from sun, from wind, from tide. So they are taking some actions too. And of course, 20% of improvement in energy efficiency. So if you realize from the manufacturers, they are increasing the energy efficiency. day by day, year by year. The next target to 2030, so it is going to be at least greenhouse gas emissions to be reduced by 55% from 90s baseline. In the long-term strategy 2050, it's going to be, the world is supposed to be zero change, climate neutral, no changes in the temperature. So there must be some more actions on that too. Simply, this part is done. The world has keep the target, it's done. 2030, 55%, and 250 will be climate neutral. Each and every temperature, 0.1 degree, is very much critical. You will be seeing it. The refrigeration or air conditioning industry is affecting too much with the F-gas, fluorinated gas, and there are some legislation on the fluorinated gas too. If we change the refrigerant, the global warming potential is decreasing, and if we make some modifications on the system of the chillers, air handling units, refrigeration systems, centralized supermarket coolings too, so we can add some value on them. We can mitigate, we can reduce the climate change. Here you see there is a graph starting from 2015, so the world is going up to 2030. So we are going to be reducing the 100% level of baseline to 21. So 79% of the decrease is going to be achieved. It has to be achieved. And then we are going to be moving on 2035 with the same level. But energy demand is increasing. Sectors are growing. So population is increasing. So we have to be going further with that. F-gas regulation, I'll be giving you the more details. That has to be some climate-friendly alternative. There must be some alternative gases having lower global warming potential. The point, very critical point with the refrigerant changes is, unfortunately, there is no one size fits all. There isn't anything in the world like that. So what they have to do is, there are some limitations. For example, the gas has to be energy efficient, service has to be provided, it has to be affordable, money-wise, you have to find it, environmentally friendly, flammability, toxicity, so you have to make an optimization on each and every limitation mentioned here. Very brief, I'll be talking about the life cycle of the refrigeration. From 1834, there were natural refrigerants, but there were some problems, like flammability was problem, energy efficiency was problem too. And once the time passes, when we come to 1930 and 50, we implemented new refrigerants, like R22. R22 was having high global warming potential and also ozone depletion. So we are just making the ozone layer is thinner and thinner. Then global warming was happening. If we come to the 70s, they started to discover some ozone depletion process. They understood that, yeah, we used to be using this refrigerant, but today they are harming to the ozone layer. So it is getting thinner and thinner. And then HCFC, hydrofluorocarbons. So these are having also some high global warming potential. And 1987, Montreal Protocol come to our life, and we are discussing some better, efficient, more efficient HFCs. And now the things are going to the 2015 F-gas legislation, and then side by side we are moving to the refrigerants, natural refrigerants. Here, what I wanted to check actually, this is the F-gas regulation schedule from the Europe. I wonder, where is Egypt? Where is Egypt? Is Egypt signing the agreement for the refrigerant changes? Yes. Egypt and Turkey, they are all in the black line of the system here. So this means that Egypt is not going to be using the previous refrigerant starting from the 2024. And year by year, they are also going to be meeting with every country in the world. So Egypt is also ratifying, about to sign the agreement for the Kigali Protocol to come to the climate neutral environment in 2050. Egypt is taking some actions too. Simply, this table and graph is showing the refrigerant system. So, GWP values, lower to higher, higher is worse, lower is better. The vacuum, low, medium, high temperatures, every refrigerant has some different working pressure. So you see in this line the density and the pressure. When you see the arrow, for example, here and here, we have new gases. We have, for example, R410A, very famous refrigerant. You see, it is high pressure, it is working under the high pressure conditions that you all know, but flammability is better. So the line, below the line, the refrigerant system you see more flammable. So we have to make a trade-off between energy efficiency, service, life cycle, affordability, money, so toxicity and the flammability. Here you see the main replacement option depending on the composition level. For example, we are talking about R410, very famous for split air conditions, for VRF. Today we are using R410. But probably they are going to be replaced with the R32, 454B, 452B. This is not something exact, something not clear, because every company, every sector is just trying new refrigerants to reduce the greenhouse emissions. For example, we are talking about the new refrigerant R454B, to be replaced by 410. So R454B is the combination of two gases that you see here. 234YF and ZE. So different gases, so they have the different composition level. Replacement options, so they are going to be replaced sooner or later. So what I can say for the HVAC-R industry, for example, supermarket cabinets, refrigerated cabinets, they are called as centralized systems. The available refrigerants, and they are going to be selected one by one. Or, for example, we can say the centralized system for the supermarkets, there are indoor units and outdoor units that are centralized. So for this kind of case, it is going to be replaced by the natural refrigerant. So today, these refrigerants are being, but they are going to be replaced with the natural refrigerant, sooner or later. Yes, there are some problems, flammability, toxicity problems, but the people are working on reducing the flammability and the toxicity of the gases too. Let's come to the replacement option for the HVAC-R industry. So for the VRF, for example, and split, today we are using R410, you see, and the safety group, the flammability group is this one. So what probably planning for the single split and the variable refrigerant for VRF system, it is going to be different refrigerants, starting from HFO or HFC's blend, R32, and it will be going to propane. Propane is very good, very low impact to the environment, but it is highly flammable. So there are some trade-off, some good points and bad points in the same time for each and every refrigerant. Industrial refrigeration, today they are using so many different gases. All of them you see here. But probably the things are going to be moving more on the propane, ammonia, and the another part of propane, different composition actually. So you see, come one back please. There are so many different things. Propane R290, this one is very good refrigerant, but highly flammable. So probably it's going to be charged with this for this system, because these systems are outside. So little risk for the flammability. Very good question I will be asking you. As you see from the table here, the global warming potential and the refrigerant gas. CO2 is only one, very low, almost nothing. But if you go to R410, today highly used, split air conditions, VRF, it is this much, 2088. But the point, let me give you something first, some information. For example, to calculate the HFC pre-charged refrigerant, 1,000 split residential air conditioners. So 1 kilogram of R410, if it is charged to a split air conditioner with a global warming potential of 2080. So what will happen? If you calculate the necessary simple calculation, just multiplication, so you see 10,000 of split air conditioners is causing this much tons of, equivalent tons of carbon dioxide. Of course. So more carbon dioxide, more global warming potential. Here is a good question I have for you. As you see from here, R32 is lower GWP, global warming potential, than R410, you see. Refrigerant charge is less, you see. And the potential of the global warming impact is less. So more efficient, less impact to the environment. But the problem, R410 is a blend of R32 and R125. Meaning that the time that they started to use 410, R32 was invented. So why didn't people use R32 from day one? So I want to remind you that I'm not here to promote any refrigerant. I'm not promoting any refrigerant. I just want to put the figures in front of you so that you make your decision to save your planet, to save your country. One generic calculation, if all R410 units were converted to R32 and the impact because of its HFC, the impact million tons, 800 million tons of the carbon dioxide equivalent, we can save. But come back to the last point, R32 is moderately more flammable than 410. Maybe that is the reason why they didn't use R32 the time that they invented 410. Here the replacement option, they are not must, they are not rules, maybe they will change. But today, the trend, the tendency of the refrigerant system from application, present, medium term and long term. So today, application of the centrifugal chillers or screw chillers, right? It's the present day, it is 134A or 123, ZE or YF. So probably it is going to be replaced by 134A, is going to be replaced with 513A, and long term it is going to be 1234ZE or 515B. Again, I'm not promoting any refrigerant. I am a manufacturer of the chillers, air handling units, package units too, but I'm not here to promote any refrigerant because each and every refrigerant has advantages and disadvantages. If we come to, for example, the scroll chillers, today, you know better than me, it is 410. Most probably it is going to be replaced by 32 and 454B, depending on the capacity. These are just like planning. And low ambient heat pump, for example, today air to air or water to water is 410. But it is going to be replaced, it's already started to be replaced by 32, and time by time it's going to be 454B or R290. And of course, long term, different. People are taking more care about reducing the flammability or toxicity of the new refrigerants. It's going to be changed. For example, process chillers. Today, 22, 134, 744. It is going to be replaced in the long term with this much. Maybe, but the things going on that way. Okay, so my part actually, air handling units, chillers, process, and the comfort chillers, I wanted to point out not only the refrigerant system, we reduce the global warming potential, but we must increase the energy efficiency. So increase the energy efficiency, there are some, of course, actions. For example, Eco-Design Directive with this designation for non-residential and residential systems. So refrigerant-wise, it is going to be currently using R410, but probably it is going to be replaced by this refrigerant, and in the end of the day, 20 years it is going to be like that. But of course, as I said, refrigerant system changing is, yes, reducing the global warming potential, but in the same time we must take some actions on the energy efficiency. So we must increase the energy efficiency. So what people are working on that, there are energy related products, ERP, tier, so tier by tier. So if you go to, for example, air handling units, I'm not able to see very well, maybe you see very well the table, right? Good. So for example, there's a new legislation that, for example, run and run coils, the minimum efficiency, it has to be 68%. Today nobody is checking maybe here, I don't know. But for the other kinds of the heat recovery system, plate, rotary wheel, it's going to be minimum 73. You have to be certified to. So there are more. Specific farm power, you know, specific farm power level, yeah, this one, SFP. So depending on the velocity, so there must be some limitation to increase the system energy efficiency. These are facts. If we go to the rooftop packages, for example, rooftops are different story. So rooftop units, refrigerant-wise, with this name of this designation of the Commission and regulation system, gas-wise it is going to be similar with the air handling units. So rooftops and air handling units today are 410, but tomorrow it's going to be replaced 32454B, and in the long run, long term, going to be replaced by this refrigerant. So we are trying to take some actions, of course. We have to take some actions. For example, in the past, we were talking about the EER level, energy efficiency rate level of the rooftop unit at the selected point. But the units are not working 100% on the selection load, 42 degree for Egypt, for example. So there are more working hours in different conditions. So what they did, they increased the level of the energy efficiency from an EER to seasonal energy efficiency rate, ECER, simply for cooling mode and for heating mode average calculation depending on the climate. For example, cooling, there are 4 capacity and 4 energy efficiency level, A, B, C, D, different outdoor temperature. So what they do, part load ratio is 100, part load ratio is this much and this much and this much, depending on the outdoor temperature. Using the cooling capacity, absorbed electricity, so based on that they are making some calculation, like ETA. This ETA value, we calculate simply ETA space heating, ETA space cooling. So if you make the simple calculation, seasonal COP for heating, seasonal ER for cooling with some correction factor, and we have, okay, units class A, class B, C, D. So we have to be talking about the seasonal energy efficiency. Same as cooling, heating mode average climate. So condition A to D from -7 to 12. And there are some equivalent too. So what they do, part load ratio, they use it, very similar calculation of the cooling, but it is this much, specific COP, and then you select the right unit. Energy labeling, energy class A, B, C, D. So choose the best efficient one as much as you can. Here you see, for example, Eurovan certification page, you see, for instance, we are talking about 30 ton of cooling, 105 kilowatt, and absorbed power, power absorbed is this much, 32 point something. So seasonal energy efficiency, active mode, so you say, as you see, they are different. ETA value is calculated as 105.5, and the energy classification based on the seasonal energy efficiency rate, it is B. So A is the best, B is the second best, and goes like this. So you see 35 at 35 degree energy efficiency rate, 30 degree another 25 degree Celsius, 20 degrees Celsius, and of course you must also be calculating the standby mode power input, maybe crankcase heater or any other active machine or components absorbing the energy. So then we have class A, class B, C, D, and E. So refrigerant-wise, there are some actions to reduce the global warming potential, and also energy efficiency, there are some actions to increase the energy efficiency of the system. So what about the chillers? Let's see the chillers, what they are doing. Air-cooled, inverter air-cooled, and water-cooled. So the norms are different. There are 3 norms. If it is heat pump unit, you see it has to be eco-design directive for different criteria. If it is comfort chiller, there are different designations for the norm. For the process chillers, for industry, for industry plants or the energy production plant, for example, so there are different norms and legislation. simply what we are going to do from 2022, 2 years ago, 2021, 2 years ago to 2030. Click on the page. Click. So what the people are working by the Montreal Protocol, Kyoto Protocol, or Kigali Amendment, that Egypt is a part of it too. So the promise is we are going to increase the energy efficiency of the system with the new norms and regulation and legislation by 32.5%. Greenhouse gas emissions by 40% reduction. We have to reduce it by the F-gas legislation. And there are some other actions too, I mentioned in the previous slides. So using the energy from the renewable sources, from sun, from wind, from tide, from different renewable energy, biomass for example. So we have to be energy used in the system by 32%. All of these actions, energy, gas, and other type of actions, is going to be leading us climate neutral. Climate neutral. The world should not be increasing too much. Simply for the chillers, for the comfort chillers, industrial chillers, and heat pumps. So they divided the products into category by category. So what they did today, there is no EER. EER is passed away. But today we have to be speaking about the seasonal energy efficiency, SEER, for the comfort cooling. Comfort chillers simply. Industrial chillers, the new designation is seasonal energy process rate. So process chillers, they are working different conditions. 7-12, they are totally different conditions. Sometimes glycol is used because they are needing year-round cooling. So different energy efficiency, seasonal energy efficiency is coming to the force. So for one slide back, I want to talk about the COP value. Simply, it is the new metric system for the space heating. Space heating for the heat pumps, reversible heat pumps, up to 400 kilowatt. So then, the summary of the actions for the comfort, process, and the heat pump systems. You see the definitions of each and everything is here. Low temperature chillers, medium temperature chillers for the comfort. For example, 712, you see here 712 like comfort, nominal conditions is different. Medium temperature chillers, where the chillers is going to be used with chill beams. No need for 712. Increase so that we make high temperature cooling. We reduce the energy absorbed by this. And of course, different conditions for the process chillers. Simply what they say for the comfort chillers, up to 400 kilowatt ETA value, seasonal energy efficiency, tier 1. But this is passed away. So now we are in the tier number 2, the second stage, next stage. So they say less than 400 kilowatt of cooling, ETA value has to be 161, and minimum seasonal energy efficiency is going to be minimum 4.1. Different capacity, air-cooled chiller, 400 kilowatt to 2000 kilowatt. Tier 1 is already cancelled, it's passed away. So we are talking about the tier 2. You see new ETA value, higher efficiency, and higher seasonal energy efficiency. Very critical. In the end of the slides, I'll be showing you what if I change, for example, refrigerant from 1348 to 513A, what will happen? And if I add the frequency inverter for the compressors, what is going to be the saving? How many pieces of maybe trees I'm going to be saving? Very simple calculations, very enjoyable. You'll be liking actually. The kind of summary I can say from 2015, F-gas regulation is coming down and the phasing down the system. So today, 18 is passed, tier 2 we are having. So you see, F-gas, the phasing down, the value, total value of the F-gas is reducing to 55%. And then 2024, 69%. We have to reduce the carbon emissions by the HFC refrigerants. And of course, as I said before, 10 years later, it's going to be minus 79. So 21, I'm going to be putting minimum. Simply the calculation, I'm not going to go to the detail, but very simple calculation, you can find it everywhere actually. The conversion factor, seasonal energy efficiency rate based on EN 40. This number you never forget. You will be remembering, you will be seeing this number again and again in the catalogs. And of course, there is a calculation where some of the negative contribution, for example, 3% due to the adjusted, the quality of the sensors, time response problems or any other kinds of problem, it's going to be affected and reduced by the total seasonal energy efficiency. Figure-wise, I can say chillers, more than 400 kilowatt, it is going to be, it was from 4.10, now it is 4.55. More efficient, it has to be like that. It is going to be like that. And Egypt, again, Egypt is a part of it. Egypt is signing the agreement. So you, whatever, consultant, designer, contracting, investor, end user, whoever you are going to be using this value if you want to save your world, if you want to save your country too. Here simply, I just put the eco-design regulation if you want to just take a picture and remember the legislation codes for the units. For example, heat pumps. Up to 400 is different category of the conditions, and up to 70 kilowatt, including residential heat pumps or small capacity of the industrial, commercial heat pump, it is going to be like this much. It has to be energy labeling. You will be seeing the energy labeling. Now you are seeing the energy labeling in your split air conditioners too. Okay, this is also the summary. Heat pump, COP value minimum up to 400, air to water. Let me show so that you really remember these numbers. Air to water, water to water. The values ETA, tier 2, the current tier, it has to be that much, minimum. So for the comfort application, SEER comfort application, lower and higher than up to 2000 kilowatt of the electric chillers, it is going to be like that. New ETA value, new seasonal energy efficiency. Chiller, 1000 kilowatt, 1300, 400. Minimum energy, seasonal energy efficiency, it has to be 4.55. And also, the chiller energy efficiency level for the tier 2 SPR process, means industrial projects, not hotels, not commercial, industrial application, up to 2000 kilowatt, you will be coming across with better numbers. You see, comfort chillers, the big one up to 4.55, but the industrial chillers, because they are running year round, 365 days, 724, so it has to be with higher energy efficiency. So with this, if we obey, if we focus, if we follow these norms and regulations, we are going to be reaching the target in 2030. What I did, simply, I have 10 minutes, so I'm going to be on time, don't worry. What I did simply, I made a case study for you. This much million tons of the carbon dioxide. What does this mean? 100 million tons of refrigerant. Sorry, 100 million tons of CO2, carbon dioxide. What does this mean? So, in the first part, existing range of, for example, around 1000 kilowatt of chillers with same compressor I put, 2 circuit, 2 compressor. Same thing, same conditions with some differences. First part is with 134A refrigerant, the existing one. Second part is the 513A, same thing. And third one, what I did, I added fully VFD, frequency converter, to the compressor, so that I see what will happen if I change the refrigerant, what will happen if I add frequency inverter, how much I'm going to be saving in terms of energy, kilowatt hour and money of course, and how much I'm going to save the environment. The calculation is very fair. I try to make it very fair, apple to apple. You see the first part is the normal chiller with the existing refrigerant, 134A. I put high energy efficient one, around 1000 kilowatt. You see the seasonal energy efficiency, 4.62. I put a higher one to make a fair comparison. And same thing, I did 513A refrigerant. You see that? 513A. So same capacity almost. You see seasonal energy efficiency, very similar, 4.62, 4.58. So this is the comparison, unit number 1, number 2, 3, 4, 5. So EER value is almost the same as you see from the graph, from the line, very similar. So let me see the result. GWP value of the 134A is 1430. So if I checked it from my manufacturing place, manufacturing facility, around 1,000 kilowatt, this much, I am using this much refrigerant gas. So this gas, together with this global warming potential, it is emitting greenhouse gases this much, 187 tons of carbon dioxide. What does this mean? We don't know. What does this mean? What is the bad impact? So GWP of the new refrigerant is very less, same amount of refrigerant gas source, very less tons of carbon dioxide. No energy, you see, the saving of the energy is zero. No, because energy-wise they are the same unit. So I see the refrigerant-wise the changes. So making the necessary calculations, just changing the refrigerant, 10 years of operation, one tree with some certain conditions, the trunk thickness 25, I'll be showing it to you. So just changing the refrigerant every year, you are saving 457 trees. 10 years of operations, but every year you are saving 457. So if we come to here, this point, now the comparison is the second and third chillers. 513A refrigerant, a new one, lower GWP, the same refrigerant, but this is VFD. So what I'm trying to underline here, as you see, because of VFD, for example, it is 458 seasonal energy efficiency, 5.03. So higher energy efficiency, especially at part load. Why I'm talking about the part load? Because 17 to 39 degree, Egypt is 40, 42, depending on the region. So only 1% time the chiller is working with these conditions. Very rare. 26% with this temperature, 25 to 35. And 73 maybe in these conditions, depending on the chain. Alexandria and Cairo is different, I know, but just to make a comparison to see the energy saving and the saving of the tree. Okay, I show you here, if you want, you can take the picture how we can calculate the carbon dioxide level. And I compare, for example, one tree, normal tree. It is 10 years of old tree, 10 years old, and 5 meter tall, and 25 centimeter trunk. So everything is here, the calculation is here. Just this unit is consequences. In the same time, the sequestered, the captured 250 kilogram of carbon dioxide. One chiller, only one chiller. So in the end, 10 years. So if we calculate the VFD chiller with frequency inverter device, you are going to be seeing 107 tons. So again, just adding frequency inverter to the compressors, so you are saving 457 trees. Just by chance, they are the same, just by chance. So CO2 capturing. So using more efficient, especially in seasonal and part load conditions, you are saving one chiller at this one. So 250 kilogram is saving, yes, 1 year is saving this much, 457 trees every year. That's all from me. If you want to ask any questions, I can come to I can find the slide and you can raise your questions.